I know. We can laugh about it all day. I know. Hurry up. Naomi will come stamp your 9.3. Well, I'll take it down.
That whole one is for 13.
Yep.
Number 13 on 9.8. So that whole thing is number 13. So the two diagrams, so that one is special.
How much is forbidden? It's called for yeah.
All right. Whether or not you've got everything, I want to get started. Yeah, he just got back, so he did 9.2 and 9.3 test today. So first of all, some of the announcements from yesterday. Why second? You were gone both days?
No, I was here.
You were here what?
I did yesterday's homework assignment today and today yesterday.
So you can only get stamped for the one.
Oh, come on, Jose. There's some slack.
I mean, everybody else has been the same way all year, so it might be nice for her, but it would be unfair to everybody else who's had the same rule all year, so I need to be fair and even to everyone. That's why I don't make exceptions, even when I love my students, and there's very good reasons. Doesn't matter, you get stamped for the one that was early yesterday, not for the one that's late. Okay. 9.2. Okay. So, check this out. Any feedback on the external environmental film? Questions about the announcements, small-scale food production signups, spring break reading extra credit assignments, anybody need the book? Surf the Summit, my friend's thing on Thursday afternoon, did I already talk to you about that yesterday? AP exam questions from anybody? Anybody have an after-school environmental film parent for us? Yeah. Cool. So can you please text message my number with your name and cell phone number, please? Thank you. Is her name Megan?
Yeah. Should it right now?
If you don't mind. I mean, there's no urgency. If you know Tiffany Iverson, you can just text her. Okay. If we've done all that stuff from yesterday, did we finish discussing number 12, the 6 things to draw from the atmospheric diagram? Did we talk about this?
I think we did a couple of them.
A couple, but not all of them? Okay. So students, I'm on number 12. And in the diagram that's on the screen, for number 12, there were 6 details to take away from this diagram. Number 1, that our atmosphere has distinct layers and each layer is independent and different. I think we talked about that, right? Like the layers of a jawbreaker. Because of the density of the gases, you have different gases and different layers. Number 2, remember that the heat source of the Earth's atmosphere is
the surface of the Earth.
the surface of the Earth. That's right. The energy source is definitely the sun, but the sun's heat doesn't reach us, only its light reaches us. Some of that light is reflected, nothing happens, but some of that light is absorbed, and after being absorbed, that energy is re-radiated as infrared, what we call heat. Rule number 3, notice that about 90% of the atmosphere is in the first 10,000 feet or so. Technically, it's about 11,500, 12,000 feet. This is why many of you feel the impact of elevation sickness when you travel to Mammoth Lakes. This is why none of us could survive more than a few hours on the top of Everest because of the shortage of gases up there. Gravity took all those gases down toward the surface of the Earth, leaving almost nothing in the upper atmosphere. Rule number 4. If you look at the diagram, you'll notice that the ozone layer, the majority of ozone, is above the troposphere. It is in the stratosphere. Ozone is basically the second layer of the jawbreaker. We've got 90% of the gases down here in the troposphere where we are, but ozone is most common above that. You can see right there, ozone concentration is highest at almost 20,000. Almost 30,000, excuse me. Ozone concentration is highest at almost 30,000 feet.
It's not 30,000 meters.
Is that meters or feet?
It's in kilometers.
Oh, wow, 30 kilometers. Okay, there you go. Yeah, that actually makes even more sense. Perfect. Rule number 5 is not actually obvious in this diagram, but you've got to know it in anticipation of later. Ultraviolet is not one thing. There are technically different types of ultraviolet. When you're in the different layers of the atmosphere, you will encounter different distributions of ultraviolet. You don't need to waste any money buying any glasses or sunblock that protect against UVC unless you plan to be an astronaut. Because ultraviolet C does not reach humanity. Ultraviolet C sunblock is like saying a stardust block. You won't need it where we live. So remember that there are different types of ultraviolet in those different layers of the atmosphere. And finally, number 6, water is a very peculiar substance. You may know that we live on the blue planet. It's blue because of its water. But what few of us stop to think about is the unbelievable coincidence, or the glory of creation, I suppose, that our planet is just the right distance from the sun so that water can be a liquid here, but if it gets hot enough, it turns into a vapor, that will rise until it cools and condenses and drops back down to us. Water is both a gas, a liquid, and a solid in our atmosphere. And that's pretty unique. That's a really special coincidence. Since water carries temperature so well, we have a really special atmosphere. Because that water vapor is moving energy up and down and up and down and up and down between the surface of the earth and the lower layer of the atmosphere. Water is a magical and unusual substance, and we live in a magical and unusual planet whose location relative to the sun gives us a really interesting and one-of-a-kind unique atmosphere. So those were the 6 things I wanted you to know about our atmosphere in this diagram, about the layering, about the heat source, about the concentration of gases down low, concentration of ozone above that, the different types of ultraviolet, and the magic of water. Anybody want to ask me about any of those 6? Because if not, I'd like to spend the rest of the period tackling what is probably one of the biggest study goals of the year in terms of its scope. Are there any questions about number 12 before I move on to lucky number 13? Okay, then watch this. We're going to discuss circulation patterns on Earth. And by the end of the period, I'll expect each of you to explain all these arrows. Now, I've taught this lesson 3, 4, 5, 6 times a day for the last 8 or 9 years. And I gotta tell you, I've seen this a zillion times with however many thousands of students by now. They're all really simple, basic concepts that every one of you is qualified to understand. The challenge is putting all these little pieces together to build an understanding of something pretty complex. So I'm going to do this in baby steps. In the meantime, Peter will work on his cell phone. I will discuss first 1 through 4 rules of our atmosphere. Then a single convection cell. Then I'll explain our planet's pattern of 6 convection cells, and based on all of that, we will discuss global currents. I want to make sure that we're all ready for this. You'll need some paper. I'll explain every word that's on the board, but I'd like to go in order, and I don't want to get distracted by somebody who's not paying attention and asking to repeat myself. Please stick with me. First, the 4 rules of atmospheric science. My hunch is all 4 of these rules are things you already know. Number 1, heat is proportional to pressure. You get to a certain level of physics and chemistry where heat and pressure are the same thing. Remember, heat is energy. When you excite molecules, they move more, they run into each other more, and that's what we call high pressure. There's more collisions between the molecules. So the heat makes them active, their activity builds their pressure. Heat and pressure are basically the same thing. Yeah.
Would you pressurize something? Does it get hot?
Yeah. Okay. So you can either heat it to increase its pressure, or you can increase pressure to increase its heat, because they're basically measures of the same thing. As long as we're talking about particulate matter, and we're not in a true vacuum, they are the same thing. Any questions about rule number 1? Heat and pressure are proportional. And how many of you already knew this from your academic life? Rule number 2. Gases move from areas of high pressure to areas of low pressure. Gases